Example, compute the area A under the graph of f of x equals 2x cubed over the closed interval from 0 to 2. To compute the area, we'll take the limit as n approaches infinity of r sub n, Riemann sums n rectangles. R sub n is defined as the summation as k goes from 1 to n of f of x sub k asterisk, that's the representation for the sample points, times delta x, the width of a rectangle. Let's find those two parts. I'll begin by looking for delta x. That width is defined as b minus a divided by n. Those are the endpoints of the closed interval. We finish at 2, so it's 2 minus, we begin at 0. 2 minus 0 divided by n rectangles. This gives us 2 over n as the representation for the width, and we need n to approach infinity. From here, we need to get a representation for our sample points. I'll start with, how about if I draw a line to represent my interval, and x naught equals 0, that's my starting point. My next point, I move over a width of 2 over n, so x sub 1 would be 0 plus 2 over n. The point after that, our x sub 2, we still start at 0, but this time we travel to the right 2 units of the width, so 2 times 2 over n. Let's do one more for good measure. For x sub 3, I'm not going to bother to write the 0 because it doesn't affect anything. Even so, we move over 3 units of the width 2 sub n. This suggests that we can express x sub k as k times 2 over n. Then we'll let our sample point, represented as x sub k asterisk, be 2 times k divided by n. We'll now compute the function at 2k over n. This will give us the height of the rectangle. The function was 2x cubed, so we would write 2 times parentheses cubed for the x, and where the x was, we'll replace it with 2k divided by n. Let's cube that term. 2 cubed is 8. 8 times 2 is 16. Then you got to cube the k divided by the n cubed as well. Let's compute the r sub n portion, which is the summation as k goes from 1 to n of the height of the rectangle f of x sub k asterisk, that's our sample point, times the delta x. We have those values. Continuing, summation k equals 1 to n, where we had f of x sub k asterisk, we'll write f of 2k over n, and where the delta x was, we'll replace it with 2 over n. Continuing, still have the summation. As k goes from 1 to n, we just computed the f at 2k over n. That was 16k cubed divided by n cubed, and we still multiply that by 2 divided by n. Simplifying a little bit, 16 times 2 is 32. That's a constant. We'll move it to the left of the sigma notation. N cubed times n, that's n to the 4th. And we'll also move that to the left of the sigma notation. The sigma is concerned with what k is doing, from k equals 1 to n of k cubed. We will now use a common summation formula for the cube. The summation as k equals 1 to n of k cubed is n squared times n plus 1 squared divided by 4. Let's replace the summation of k equals 1 to n of k cubed with that replacement. So now we've got 32 divided by n to the 4th times n squared times the quantity n plus 1 squared divided by 4. Let's continue with our algebra. This would be 32 n squared, the quantity n plus 1 squared, divided by 4 times n to the power of 4. Some of this simplifies really nicely. 32 over 4, that's 8. In the numerator, you'll still have the n plus 1 squared remaining, the n squared in the numerator, and n to the 4th in the denominator, reduced to n squared in the denominator. Now we'll go back to the very beginning. The area is equal to the limit as n approaches infinity of r sub n, which would be the limit as n approaches infinity of 8 times n plus 1 quantity squared divided by n squared, and this is 8 units squared.